Thank you, Marion, for the questions. I propose next presentation that is presented by Boutin from SNCF. I need some help to close the previous presentation. Please give me. I can. So I let you to introduce yourself. You'll start your presentation.
Okay, thank you. Thank you, Vincent. So, hello everyone. I'm Judica Boutin. I'm from SNCF Réseau. It's a pleasure to present you the result of one experimentation around using BIM and GIS technology to reach specific objective on railway maintenance. That's something specific. I will. This presentation is in two parts. I will present the business part of this work, and I have Content Market, who is online, cannot attend physically, and he will show its video on the technical part of this presentation. And by the end, for question answer, he can also support the presentation. What is just about just a few words about SNCF Réseau. SNCF Réseau manage the French railway network with just to highlight the kind of activities of SNCF Réseau is to manage 30,000 of kilometers line in France, and it's about 1,600 work sites in France with 15 passenger train per day. So that means that behind the SNCF activities, the maintenance is play an important role to keep this capability always operational. So that is a key issue on that. We need to keep the railway always operational. So the experimentation on the using BIM is to how BIM can help this and how we can use BIM for that. So just a few words of BIM deployment in SNCF before start to the core of the presentation. We have a deployment of BIM in 3 phases at SNCF. The first phase is about development of the skills. Skills mean manage the maturity of people, manage maturity of tools, and manage technological integration of the different tools that can be used to have an integrated system that works. And the second phase is about industrialization. That means BIM mandate. That means generalizations of BIM tools, and that means using information coming from BIM for different process, where the objective is make the railway function. So by the end, the objective is to reach step by step by end-to-end digitalization of the railway system by overall. So that is a global railway. And to come back to the experimentation contest, we use BIM on 30 kilometers of length in south of Paris. And the idea is to check how the BIM and the BIM philosophy can help to do that. And the starting point for this is to use existing data. Existing data is something classical about different kind of CAO information from the different sources, but it's also massive data coming from the LIDAR data, point cloud, and massive data coming from the line side, database, internal database, geolocated database. So the first step is to have to manage all that to create. It's not that. To create, first of all, the track, like 3D, in 3D, that's a different asset on the railway. That's the first step and the first layer create. So the main issue here is how to use rail length, many kilometers rail, and to manage really the count, to manage the 3D aspect on that. That is to be really usable, using information starting from 2D information, just point cloud, in order to be able to industrialize something and to do massively this task, because you imagine that if you start digitalization always railway system, we need massive algorithm, we need something really to be able to use in context of massive data. So that is some issue here. And to come back to the maintenance aspect, what we need to maintain and how can we create digital model for that. The idea is first of all to identify how, if we start, the starting point is design, how the design can take into account maintenance issue to have the right digital model. So we start to analyze the asset we need to manage. For that, the maintenance issue on track, for example, is really about track defect. We need to identify track defect, and there are many databases behind that. We need to define geometry, because at the beginning of the railway system designing, the design is made by geometric tolerances. That is a track, because it's a requirement to keep the train on the track. So this requirement is used to make some monitoring of the system right now. That's something real. And we need to have connection with the associated database. And we had also to manage turnout, because turnout in the railway system is something really critical. We are monitoring that really precisely. And by the end, you have some how to represent those information in digital BIM. That means that if you have some kilometer of track, you need also to manage how, at which moment you have some changement of the for example, your digital model need to be able to have this representation in order to associate database on that. And something more simple is about preparation of punctual defect. That is, for example, track defect is just what I see the next slide there, for example. We need to point out that something you cannot see visually by, you imagine the guys who is need to find the maintenance to check where the real defect is something 1 millimeter, but so it's not possible. We have some monitoring tools to do that, and to help the people who need to go and to check and monitor that, or to make something on that, we need to have comprehensive. The idea is to make BIM able to do that. And we have this phase is about representation of this default on using dedicated representation. That is subjective, but we the one kind of representation that helps to represent this digital model in the comprehensive 3D environment. So the end of this is that we create by is not a process from design, it's just something created from the massive data, connecting multi-source data, and this connected these objects in the digital model. And using different techniques of which Quentin will present next, we test many tools on this process to evaluate the capability of different tools, different capability to bring this information in this context 3D model. By the end, you have some people who need to maintain the track. The idea is that he can have this 3D model and click on it and have database coming from directly the database maintenance to have in the field, for example, that this information in to make the right action for maintenance. And by the end, we have integration of all this model around the 30 kilometers. and we make some tests to evaluate how this model, because the idea is first of all to create that, connect that to the real database that is used for plane maintenance, and by the end the idea is to bring these information to the right people who need to use that. So to do that we try to test many technology on that, how the combination of multi-technology, GIS and CAD world can work, and what is the issue on that. Can we say that everything is okay for that, or is some issue on that? I think Quentin will come back on the test we do on that, on this in this idea. But for the business side, what is, I mean, maybe the grail for operator, which is SNCF, for example, on this maintenance, is to say we have a digital mock-up. This kind of thing may come from the design. That means that the people who design the track, with the information he has, so the different kind of track he have, you can see it visually. He prepared the model by the design phases to have really the different heterogeneity of the track. You have some sleepers different, you have some different kind, which is massively done by the machine, and where is the changement of that is not the same way you have to maintain them. So for the people who maintain that, it's important for the design phases to have this information to be able to connect some other source on that. If the guys of design don't have this information, is something more difficult to do later on. So you can anticipate that. That is something really nice. And if you have some kind of model, what you see in the screen is we have some different filters of that. And what you see, for example, in red, that means that the next maintenance operation will be done next week. So you imagine that if this information we can be able to put in for the people who plan maintenance, he will avoid to go to the field to show exactly what he needs to do. And he can play for this at the office exactly where he want to go plan his maintenance. Instead of go overall the 13 kilometers to show where to do the work or to fix exactly what is the issue on the track, he will just use his database where all this information is available and put it in BIM data and have visual view on that and focus really on what he want to do and what is the right moment for which is the action to do next week, for next month, and in the planification. So that we expected that we can be able to make this application available on a more real site, because we do it with the maintenance guys, but actually the database is not continuously connected to digital code. We need to test and to find how to make that, but also to have this kind of way to take into account the maintenance operation from the design side. If you have the track model, we hope that this kind of representation of track is taken into account in order to facilitate the connection of the information coming from the database, which is globally GIS database. That is the immediate objective. So now I propose you to, for technical aspect, we try and we test many things. I left maybe the video of Quentin who will present you the different steps we do to have this result. So if we can have the video, thank you.
Hi JDK, many thanks for your presentation. I'm Quentin, a BIM and GIS consultant subcontracted by SNCF Réseau. In this chapter, we will talk more deeply about software and data flow information. For the first experimentation about maintenance model authoring, we used Dynamo visual programming to link external alphanumeric data to 3D solid coming from corridor in Autodesk Civil 3D. This workflow was admissible for rail or ballast areas, but we discovered some deficiencies about slippers implementation. We had objects, massive rehearsal, and maybe it will be smarter in the future to use a GIS approach with 3D symbology. In fact, whatever could be the physical representation of a slipper, timber, concrete, or by-block slipper, it would be preferable to use only points and change stylization on the fly. Moreover, to use Dynamo, we had to use IT robots programmed to extract and so duplicate information from internal data lakes. Still, with a GIS approach, we can expect to complete a better job in the future by a direct connection on urbanized data with our new Trimble query and Connect command data environment. Connectors are the key to the success. The project was completed in 2 phases. Phase A, experimentation on 1 kilometer length. The IFC export is about 184 megabytes without the terrain. For the phase B, it was the full maintenance area described previously by JDKL. For 30 kilometers, we have 2.5 gigabytes IFC still without the terrain. The last one was too big to be created in only one part, so we had to split it in 3 areas. As you can see, with the files wave, BIM models are not the best solution to support the full tracks managed by an infrastructure owner such as SNCF. Initial IFC file for a 30 km maintenance area was so important that some SaaS platforms were not able to read it. Here, for example, the Mesoteam command data environment from Prozis. It required to split in several small length areas to open it on the cloud, still without the existing ground. So that was not possible to have our terrain with IFC due to an important linear and numerous tracked internals. We decided to start experimentation about CTGML format. CTGML is an open standard issued by OGC. About it, please look about their new logo. We had several levels of detail representation and are very different that we can have for BIM model and new ISO 19650 definition. To start writing CTGML, we reused former investigation about FME middleware and former scripting. With VRMS distributor in France, we were able to recreate geometry coming from GIS data tables by fixing a solid tree construction upstream. Thanks again to this team to inspire us and complete our first step alone with FME Workbench. Moreover, to identify the main useful transformers allowing to write or transform CTGML, we had access to several samples coming from safe software. Do not forget that this technology is the only way to bring back files to AutoCAD, to Autodesk Map3D, InfraWorks, or Esri ArcGIS ecosystem. The first step was to write CTGML directly from a native model authoring file format. We discovered just how to complete scripting, and we didn't try to optimize the features in correct classes. We just used generic city object. We had a surprise for the 22 GB waves due to slippers representation. For the future, we will for sure investigate 3D symbology for slippers. Unfortunately, very few viewers can read directly CTGML, especially in 3D. Some of them can only open in 2D, such as QGIS. CTGML is a complex data model and requires very large files. Each of them can be directly edited by a simple notepad. About geometry, CTGML uses only boundary representation, named BREP, and cannot use the CSG or sweep path representation. The second step was to write CityGML with simple feature, no longer as a generic city object. Randomly, we choose what sounds the most similar object without integrate the potential links between several CityGML features or parts. After all, when you are discovering CityGML classification with an ETL tool, all features are listed by alphanumeric order. A transformer dedicated to appearance allows us to keep different colors, and we discovered that FBIM software from CSTB can load several GML files and aggregate it without the requirement to have all placed in the same file. 55 features are standardized in CityGML format. Each of it has its own requirement related to level of detail 1 to 4, following also the kind of geometry, solid, multi-surface, multi-curves, and so on, and feature roles. It is more complex than we thought to find the correct combination and succeed to write CityGML files. After completing the first script dedicated to simple features, we started our investigation about advanced design, especially about bridge and tunnels. The process is still ongoing. The job is very different due to the assembly of features for a bridge. You can see the UML diagram on the right, and you will have to manage bridge construction element, bridge furnitures, bridge parts, bridge installation, and bridge rooms. There are numerous sub-features. Of course, you will have also a similar definition for tunnels. Don't forget, whatever you are working for bridge or tunnels, that the structure is based on a road, so a transportation part, also linked to the terrain. Semantic and topology representation must be taken in consideration. Until now, we just worked about translation of native files to CityGML format. The next goal is to be able to convert directly IFC files to CityGML. On the screen, we already have experiences to write it with an ETL tool, but we still need to investigate how to transcribe IFC places in BREP and keep alphanumeric data with attribute mapping. Cherry on the cake, FME Workbench has transformers allowing to bring back to the geographic context some design produced by non-linear tools such as Autodesk Revit. We didn't start again to have a look about it, but it will be a future challenge. So, once again, thank you for your presence and for looking this movie. Whatever where you are coming, please enjoy your trip in Lyon in January 2022. Thanks.
Okay, thank you. So as you saw, we have this job. If you have some question about the business phase, I can ask you. I don't know if content with us. We cannot. I don't know if you can connect with content to answer directly. If, normally it's online for technical aspect. But in general, just to summarize what we do here is have some we have some issue managing massive data. If you have maintenance issue, it's not just project scale; it's something bigger. You have some people who need to manage larger scale, and the idea is if we don't have digital twin available, we need to deal with existing data to make something. The first step is to create data, to share it, and to make many manipulations to have comprehensive to working on BIM environment. So the idea is to test many and also to evaluate the gap between what we are able to do now and the step to go further, and what we need to do to improve the process and to prove the tool who are able to help us to make this kind of issue. So if you have any question, thank you.
Thank you very much, Judicael. It's very impressive what you have shown just before. Once more, the SNCF strategy, vision, and what you it's very inspiring for us to go ahead in the deployment of digitization of the activities. So it's very impressive. Thank you. Marion, do you have any question on the BRELA, or are there any questions in the room?
No questions in BRELA yet, anyways.
There are much more people in the room than before, so if you have any questions, yes, then.
Thank you, Judicael, for your very nice presentation. So, as far as I can understand, your strategy now is not to focus on just on BIM, but to focus on GIS for operating and maintenance support. So the thing is, do you have right now specification for BIM model that company will produce for you in different projects to allow you to implement your tools easier or in a more efficient way into your database? Do you already have something that we have to do, or something that we surely not have to do to allow you to implement it quickly and safely?
Yeah, very good question. I think we are trying to make something in the contest. We need to produce, but we'll also need to develop something to integrate. So it's something we need to do step by step. And right now we don't have clear specification on maintenance phases, but it's something we are working on. And what we have done yet is always to say, okay, at design phases and what is in IFC project to specify a P set. That is, we know that at design phases, this information is always available. Typically, if you have a design phases and you have some track, you know exactly what is the monitoring you need to put in place to monitor this kind of track you implement. So this information is always available in BIM model. So you can always come in for the designer specification you have. You can always put this in the model, and we cannot say that the specification process right now is always okay to manage all that in specific way, because people who are working on it is not BIM language speaking all the day. So it's something we will do progressively. But the kind of experimentation we present is put light on other aspect on that, geometrical aspect, or structure the BIM model to be able to connect information that is not possible. If we come back to the track we saw, we imagine that the designer put just one track for the beginning of the end of the line. You need to take your cutter and your model to say that, okay, this, and to create new object and to associate it. That is, you don't know which in the system can do that, because the system don't identify people who have this job to do. So you have a problem in your system. But if the designer take this into account, it can produce you directly a model that is shaped for you, that is shaped for maintenance, and that is the objective for this kind of experimentation also. To have directly by the maintainer what is the requirement for that. What is expected really? Is it the track? Is it the slippers? Or is it just in detail? Or is it just which is point kilometer you want to change the game and to be able to connect object? If you don't have this connection, you cannot do that. Or you need to put one layer of software on that to be able to do. So you make a layer of software, and cost, and performance also is not there. So I don't know if I answer the question, but everything is not clear. But we have this in is really concrete, in concrete way is the objective of this kind of experimentation, to make the requirement clear.
Any other questions?
Actually, we have one question from Umbrella now. If there's time for one more question.
Yes, go ahead, Marion.
Yes, Thomas has a question. Have you already investigated what the new alignment features from IFC 3 can help you for the integration of the data?
Not understand you. There is an echo.
Okay, should I try once more? The question was, have you already investigated what the new alignment features from IFC 4
sorry, Marion,
can help the integration of linear data?
Marion, we cannot understand you. Sorry, there is an echo, so that we cannot understand you. So I propose that you send an email.
Once more?
No, it's a technical issue.
Is there now an echo?
Can you switch off your sound at home, Marion? Maybe it's...
So once more the question, have you already investigated what the new alignment features from IFC 4.3 can help you for the integration of linear data?
Maybe Quentin, you have understood the question. Maybe Quentin, you can answer. Can you switch on the mic of Quentin, please? We cannot hear you, Quentin. we see you speak, but we cannot hear you. So we are a little bit late. I propose to go ahead because for the people who join the, it's okay. Okay, go ahead, Quentin, if you have understood the question.
Can you hear me? Okay, perfect.
The question is on.
We use the CD3D and we don't have
No, it's not better. So sorry for everybody. We cannot. Okay, Julie, okay.
I can try to reformulate your question, Mario. Maybe if I'm okay, if it's okay, you tell us. Do you mean that if we check the IFC 4.3 specification, able to support what the experimentation we done? Is this the question? Mario? In this experimentation? Yes, I think for this experimentation we only work on geometry, first of all, because many work on that first. And we don't really work on the specification. So the IFC 4.3, the main issue with that is information, is semantic. But so we don't use really IFC 4.3, we use existing tools. You can confirm, Quentin? Existing geometry, so since it's just geometry, we don't need AFC 4.3 for that. So it's
okay. Once more, Judicael and Quentin, congratulations for what you have carried out. For the people who join late, we cannot. We start before the time because we cannot. The speaker number 2, but I joined the session, Umbrella.